Hi everyone, this is Dr. J. Ravindranath Reddy working as Assistant Professor in MLR Institute of Technology, Hyderabad. So in this video, we are going to discuss how to find out the Fourier series of an odd function in the interval minus L comma L. So in the previous video, we have seen how to find out the Fourier series for even function, neither even nor odd function in the interval minus L comma L. So in this, we are going to see how to find out the Fourier series for an odd function in the interval minus L comma L. So here first we will see the definition, what is an odd function, and then we are going to see how to find out the Fourier series of an odd function in the interval minus L comma L. Now let us go for the definition of an odd function here. So let us take the function f of x here. So now replace that x with minus x in the function f of x. So after replacing that x with minus x in the function, if we get that value is equal to minus into f of x, then this function we can call it as an odd function here. For example, I am taking one example here. So let us take f of x is equal to x cube, or let us take f of x is equal to x. Now replace this x with minus x in the function. So f of minus x is equal to minus into x. So if you replace this x with f of x here, you will get this value is equal to minus into f of x. So here we got that this condition f of minus x is equal to minus f of x. So whenever this condition satisfies, then we can say that the given function is an odd function here. Now we are going to take one odd function, and for that odd function we are going to find out the Fourier series in the interval minus L comma L. So now before that we will take the standard formulas to find out the Fourier series of an odd function in the interval minus L comma L. So this is our standard formula. So f of x is equal to summation n is equal to 1 to infinity bn sin n pi x by L. Generally we have the formula, this is equal to, so a naught by 2 plus summation n is equal to 1 to infinity an cos n pi x by L plus summation n is equal to 1 to infinity bn sin n pi x by L. So this is our general formula to find out the Fourier series, but here whenever we have the interval in the form of minus L comma L, so if the given function is, if the function is f of x is equal to an odd function, so while you are finding that a naught value and an value, so these two values becomes zeros. So here we have the formula 1 by pi integral minus L to L f of x dx. This is the formula we are having to find out a naught value. So since f of x is an odd function here, so whenever we are having an odd function between the limits minus L to L, then we can take this integral value is equal to 0. So here we will get a naught is equal to 0. And similarly, whenever you are finding the value of an, we have the formula 1 by 2 pi integral minus L to L f of x into cos n pi x by L into dx, and the given function is here, this function is an odd function, and this we know that this cos is an even function. So whenever we multiply one odd function with the even function, then this resultant function it will be an odd function here. So once again here in between the limits minus L to L, if you have an odd function, then this integral value can be taken as 0. So because of this reason, we are neglecting this a naught term and an term. By neglecting these two terms, you will get only this term which contains Bn. So that's why we have taken that Fourier series as n is equal to summation n is equal to 1 to infinity Bn sin n pi x by L. Because of this reason, we have taken this formula to find out the Fourier series of an odd function in the interval minus L comma L. Now similarly, next Bn is equal to, now it's time to find out the value of this coefficient Bn. So this Bn is equal to, so here also we are having that Bn, if you take the same formula here, Bn is equal to 1 by pi integral minus L to L f of x into sin n pi x by L into dx. So this f of x is an odd function given in the problem, and this we know that this sin is also an odd function. So whenever we multiply two odd functions, then this resultant will be an even function. So whenever we are having an even function between the limits minus L to L, so this can be written as 2 into, so that is 1 by pi into, this integral minus L to L can be written as 2 into integral 0 to L, and the same function f of x into sin n pi x by L into dx. So that's why we have taken that Bn is equal to this value here. It's 2 by L integral 0 to L f of x into sin n pi x by L into dx. Now by using this Bn, we will find out the value of Bn. We will find out the value of Bn and we will substitute that Bn value in this standard formula. Now let us take one example how we can find out that odd function, Fourier series of an odd function in the interval minus L comma L. So this is the function I have taken, f of x is equal to sin ax, and for this we have to find out the Fourier series in the interval minus L comma L. So whenever we want to find out Fourier series for any function, we require the interval where we have to find out that Fourier series for that particular given f of x. Now this is the interval, now this is the function, we are going to find out the Fourier series. So now whenever we are having the interval of the form minus L comma L, then we have to concentrate on the function f of x and we have to check whether that function is an even function or odd function. So now let us check whether the function is an even function or odd function. So already we said that whenever we are having a sine function, then that sine function it is an odd function. So here that's why we have taken, since sin ax is an odd function in the interval minus L comma L, then the required Fourier series, it will be of the form summation n is equal to 1 to infinity Bn sin n pi x by L. This is the standard Fourier series formula for an odd function in the interval minus L comma L, and here we are having only one coefficient, that is Bn. So that Bn is given by 2 by L integral 0 to L f of x into sin n pi x by L into dx. Now by using, we will find out the Bn value by substituting this sin ax here. So now Bn is equal to 2 by L integral 0 to L. So in place of f of x, I have taken that function as sin ax because he has given that value f of x, sin n pi x by L into dx. Now once if you observe this function inside the integration, you are having sin, it is of the form sin a into sin b. So we have the formula. So now we have the formula 2 sin a sin b is equal to 2 sin a sin b. We have the formula. So here we want to, so I want to multiply that numerator and denominator with 2, otherwise, so already here 2 is there outside, so you bring this 2 inside this integration here. So it becomes 2 into sin ax into sin n pi x by L into dx. So this suitable for this formula. Now apply that formula. So we have this 2 sin a sin b is equal to cos of a minus b minus cos of a plus b. So here a is nothing but a, capital A is equal to, we can take that value is equal to ax, and b, capital B is equal to n pi x by L. Now in this substitute a value and b value, so you will get, so cos of a, that is ax minus n pi x by L, I have taken x common, minus cos of a plus b. So this is our required form here. So now we are ready to apply the integration, because inside the integral we are having the two terms are there. So separately apply the integration of first term and integration of second term. So now 1 by L integral of first term. So you, for some time you consider this as x. So this is of the form integral of cos x. Integral of cos x can be written as sin x. So that is sine of this function. And once again you apply the derivative of this remaining function which is inside this cos and write down the derivative value in the denominator. So you will get a minus n pi by L is a constant and derivative of x is 1 into this coefficient. We will get this one minus, similarly you find out the second term integral of cos of this. You will get sine of a plus n pi by L by this one. Now substitute the upper limit and lower limit here. So substitute x is equal to in L, first upper limit. So if you substitute x is equal to L here, so otherwise you simplify this, you will get this, you write down this L to 0 to L, simplify this AL minus n pi by L. If you substitute that x is equal to L here, this L and this L gets cancelled and write down the remaining denominator as it is, minus here also you simplify this, you will get, take the LCM here, AL plus n pi by L. So totally you will get AL plus n pi by L, and if you replace x with the upper limit L, this L and this L gets cancelled, you will get AL plus n pi by the denominator. And if you substitute the lower limit x is equal to 0, you will get 0 into anything equal to 0, sine 0 is 0, 0 by anything equal to 0. So if you substitute this lower limit x is equal to 0, this term and this term you will get that two terms are equal to zeros, because we have the value sine 0 is 0. So by neglecting this upper lower limit here, so we have substituted that only upper limit and this is the value we got here. Okay. Next, once if you observe this, after substituting this lower limit and upper limit, these are the two terms remaining. So once if you observe these two terms here, this is of the form sine of a minus b, sine of a plus b. So now you expand this by using this standard formula. Sine of a minus b is equal to sine a cos b minus cos a sine b. So you expand this. So a is al and b is n pi. So sine a, that is sine al cos n pi minus cos al sine n pi. This is the expansion for this. And here similarly, here it is of the form sine of a plus b. So sine of a plus b can be written as, so sine a cos b plus cos a sine b. Follow the same formula and this is our required formula here. So now in the next step you substitute the value of cos n pi, and here we are having sine n pi, so we can get that value is equal to 0, and here also we are having sine n pi, we can replace that value is equal to 0. Sine pi into anything equal to 0, so this entire term, these two terms gets cancelled here because these values are equal to 0 because of sine n pi. Now the remaining one is, this is the remaining term and this is the remaining term. So finally we will get this. So sine al cos n pi by denominator minus, only this is neglected since it is 0. So sine al cos n pi by a plus n pi by l. This is our final value. So if you want, you can simplify this. Otherwise, you can take this in both terms. These are the common we are having. So you take sine al cos n pi outside. This is the remaining terms you will get, and simplify by taking the LCM here. This is our final value you will get here. So Bn is equal to sine al, this cos n pi, we can take this cos n pi as minus 1 whole to the power of n by L. After simplification of this, this is our final value. So if you remove these brackets here, you will get minus a, this a and this a gets cancelled, and this minus of minus, this becomes plus n pi by L. So n pi by L plus n pi by L, you will get 2 n pi by L, and this is a minus b into a plus b. So this can be written as a square minus b square. This is the value you will get here. So now we got that we have taken that bn value is equal to this. Now only bn coefficient we got this. Now you are ready to substitute this bn value in the standard formula. So this is the formula we have considered for the Fourier series in the minus L comma L for odd function. Now we got the BL value, substitute that BL value here. So this is the BL value what we got in the previous. So just I have replaced that BL with this value here. Now simplify this. So here this summation is applicable for n. So if you have any terms other than L, you take that terms outside that summation. So here sin AL by L. So in this we don't have n here. So this becomes a constant. And whatever the terms involves n, you keep that all the terms inside this summation, because this summation is applicable for n. So now simplify this. So finally you will get these values. Sin AL by L, summation n is equal to 1 to infinity minus 1 whole to the power of n sin n pi L. Bring this denominator to the numerator. So it becomes L square by a square L square minus n square pi square, this one. So this one L gets cancelled here, and this L also gets cancelled. So finally you will get 2 n pi L by this denominator into sin n pi x by L. Okay. So this is our, after doing some simplifications here, finally we got this is our required Fourier series expansion for an odd function, that is our function is sin ax in the interval minus L comma L. So this is the way how we can find out this Fourier series of an odd function in the interval minus L comma L. So next, in the next video we are going to discuss how to find out the half range sine and cosine series of the function f of x in the interval 0 comma L. So we will discuss this in the next video. Thank you all of you.